Good afternoon, everybody. I'm Karen Muldowney. I'm Business Development Manager with Shapoorji, Pallonji. We've been in Ireland now for a year. The company itself is a large group based out of the UAE and India. Our group turnover would be 6.5 billion. If you haven't maybe seen us on our hoarding, you might know that we sponsor the Irish Cricket Training Academy. And I think that's due to the relationship the Mystery family have with Ireland, the fact that they carry Irish passports. So it was a decision of theirs to base themselves in Ireland, a European headquarters, for a number of reasons. Obviously, their allegiance to Ireland, and of course, maybe the low corporation tax as well that we offer. I'm going to really talk today about a rapid form of construction that we did for Intel in Bangalore in India. We JV'd with ACOMS on this, a 99% JV by Shapoorji, and it was a top-down construction which enables a high-rise building to be built from the ground floor up. And like I think the buzzword at the moment is very much modular construction and rapid construction. And this project here would demonstrate the advantages of embracing these forms of construction. I'll just give you a very quick overview on this.
Precise jacking system. SP is implementing this methodology for the first time. In fact, a building with this design and construction methodology is being built for the first time anywhere in the world after the early 1970s. The floors are cantilevered from the 7 cores and positioned at the required levels by locking beams that transfer the floor loads onto the 7 cores and the foundations below. The cores house the elevators and the stairwells. Thus, there are no columns anywhere in the floors. The construction sequencing also meant changes in the procurement plan. The facade subcontractors and all MEP subcontractors were required to be on board even before the commencement of the civil construction. While Intel was busy securing the building permits and sanctions, SP mobilized and set up its temporary facilities for the project and started pre-construction activities in April 2014. Oh wow!
As I said there, we started in April 2014 and we completed that project in early 2016. This involved the construction of 600,000 square foot of lab and office space over 10 floors. The cores here are the heart of the project, and the cores were built using a slipform construction. Precise planning was required to ensure that the cores were completed on time and within the tolerances. This project was delivered with BIM. I have a few more videos that will explain this in more visual, but I'd like to quickly run through the key points for top-down construction. This can save over 50% on a program, which has effects on your costs and on your labor. The savings obviously on prelims. We know right now we have a shortage of labour within the industry, so the more that we can bring into the factory and check that quality on a factory floor, the better. There's substantial return on investment due to the early use of a building. You've more usable floor area as you've no columns. But I suppose the key point here to know is with top-down, top-down doesn't dictate the design dictates how we go about doing top-down. So if we're thinking about doing top-down, we can go and do our design, and then we can work around doing the top-down. There's huge savings on prelims, as I said, and obviously premium space with no columns. The design is open space, which obviously brings about more flexibility. There's floor use and layout can be amended. There's 10 to 15% gross internal floor area. It's actually something, this project that we completed was on a brownfield site, but actually can be completed on congested sites. So for inner city Dublin, it's a project that we're actually exploring with a large developer at the moment on. The site conditions are less risky in the poor ground and less invasive foundations. The quality, obviously, modular construction, because we're manufacturing a lot of this either in a factory floor or on ground floor. We can there's less defects and improved maintenance. And the fact that we're doing these high-rise building on a ground floor level, there's obviously less safety implications, no working at heights, no requirements for tower cranes. I'm just going to flick on to the next video here, which kind of, I think the visuals of it will be quite good to look at.
The works related to slip forming, the 46-meter-high reinforced concrete cores were immediately taken up. Keeping in view the specification for the dimensional accuracy, geometry, and the verticality of the slipped cores, SP engaged a specialist slip-form subcontractor from Dubai. 4 sets of self-climbing slip forms supported by jacking were deployed to achieve an average lift of 2.55 meters per day. One by one, the 7 cores were cast, including positioning the cutouts, inserts, and the embedments to receive the locking beams. The best time achieved for slip forming a core was 13 days. All the 7 cores were built in line with the planned schedule. Once the cores were completed, the works for installing the staircase flights and lift cores were taken up inside the 7 cores. At the same time, heavy-duty lifting jacks were installed on top of the core walls. Each core was mounted with 8 heavy-duty jacks with a combination of 100 tons and 180 tons depending on the lifting load in the corners. While the substructure and core walls were being built, the procurement team had finalized all the specialist subcontractors for the structural steel, facade, MEP disciplines and the elevators. The order for all capital equipment were released even before the core walls were built. The structural steel was fabricated at the subcontractor's manufacturing plant as per the approved shop drawings. The entire stock was inspected at the factory prior to its delivery to the site. The assembly of the roof slab began in early September 2015. The job required very high levels of precision and control to achieve the specification and tolerance limits for camber in steel deck assembly. Once the floor frame was ready, the deck sheets were laid on top of it. The floor was then jacked to an intermediate level of 2.1 meters to allow fireproofing, facade installation and MEP first fix in parallel. The reinforcement and the floor concreting followed, all at the ground level. The activity of concreting was planned in handling stake of slab to ensure that all the cambers in steel flattens with dead load of concrete while the concrete is in wet condition, as there are minimum cracks in the slab while the cambers flattens. The brackets for fixing the facade panels were then installed along the periphery of the floor. The facade panels were then installed to the floor and aligned. Parallelly, all rooftop service equipment were loaded on the floor. The floor, weighing around 1,500 metric tons, was now ready to be lifted. The floor was then sprayed with fireproof painting underneath. The MEP subcontractors followed thereafter to install their ducts and pipes underneath. Once this job was completed, the jacking of the roof slab started on 1st October 2015. And it took just 8 hours for the roof slab to be positioned at the required level. The locking beam installation below the roof slab was immediately taken up and the floor was released from the jacking cables. After this, the roof waterproofing and the rooftop services were taken up. This sequence was repeated for all the floors and the knuckle portions till the entire structure was built. Over a period of time, the project team improved significantly on the cycle time. This involved close coordination with subcontractors to ensure timely delivery of all the required materials for each floor. The total structural steel consumed is to the tune of 4,400 metric tons. The work sequencing was also closely monitored to meet the program requirements. The materials required for the interior fit-outs were simultaneously being loaded onto the floors before they were lifted to the required positions. All the floors were locked in their permanent positions. The glazing, louvers and ACP cladding area adds up to about 40,000 square meters. The entire work of the building and raising the 10 floors was completed by end March 2016. The conventional sequence of construction was thus turned on its head with the use of the top-down construction.
Sorry, I was trying to edit that earlier on today and I've missed a few bits in it, but I think it kind of gives the message of what this form of construction is. I know there's a lot of you in the room saying 50% and whatnot. We also have to realise that as well is working conditions in Ireland are a little bit different to India. We can do day shift, night shift in the rotation of the work. So it's maybe, whilst we're saying 50% and we can demonstrate we have a 50% saving on that project, we also have to note that that was also done during night shifts as well. But it is something that can be done here in Ireland. As I said, we'll be looking at it with a developer here in Ireland, and we do believe that we could at least give 20-25% saving on his building. In order for us to grow in Ireland, I think we need to embrace these technologies. Our company is investing a huge amount of money in R&D. As I said, this project was all delivered in BIM. We have a BIM design centre based in Dubai, but again, we're looking to align ourselves with local partners here. I think we're all becoming aware modular construction is the way forward, and I think what we all have to do is embrace these technologies. So if there's anybody would like me to send this video to them, if they want to come over to me, and I can send them the video, the long version of it. Thanks very much.